Are we rocking and rolling?
Yeah, we're on air.
I am on air. I am live and in person from Ho Chi Minh City, District 2, the American School. First video, period 2. Are you excited? You look excited. Excellent. Okay, good. So what we're going to do today is we're going to try to connect the last 2 preliminary lessons. In other words, the lessons that are previews to the beginning of the chapter. See, this chapter is on scientific measurement and the reduction of data, making it usable. You find the mass of something, a piece of metal, doesn't really mean much, right? You find the volume of that same piece of metal, and now you reduce it. You take the measurement correctly according to reading scales, and then you divide, mass divided by volume. You're reducing the data. Now I have something very useful called the density. With other observations, I could actually use that number to find out the identity of that metal. So what I'm doing is I'm reducing the data. So this chapter is on reading scales, finding measurements, reducing data using multiplication, division, addition, and subtraction, square roots, whatever the case may be. Clear? Good. Now, so let's just, there's a point to this because we want to start. The first section in the book is in the chapter Scientific Notation. And we've not been using scientific notation. Now, many of you are in advanced math classes, and you certainly have enough math background to be able to recognize scientific notation, correct? Not that hard, right? Okay, good. So let's find these measurements. I have 4 measurements, okay? Let's say it's 1, 2, 3, 4. This is scale A, B. First thing I want to do is I want to find the precision of each scale. Remember, you must read every scale, no matter where, no matter when, no matter what, no matter who. Sounds like a song, doesn't it? Those are words of a song. I can't remember what it is. The same. You got to read everything the same. 1 estimated place value. Clear? So I know that this is 10,000s, correct? 1 less than 10,000 would be thousands. 1 less than thousands would be hundreds. So it's going to be plus or minus 100. Clear? So the precision is hundreds. Clear? Yes? The lowest place value, in other words, this is what I just said. The lowest, the precision, I'm kind of defining precision again in a different way. You ready? Precision is a place value, the lowest place value, that contains a digit from the instrument. It represents the lowest place value. It's a place value, hundreds. It's the lowest place value that contains a digit read from the instrument. Now, let me rephrase that, and I'll introduce an entire section to you from the chapter. Yes? Any digit, any number that's read from an instrument is significant. Yes? That's an adjective. It's significant, correct? But we also use significant as a noun. A significant digit, a significant figure is a noun. And a significant figure is any figure, any digit, any number read from an instrument. Clear? And the precision is a place value, the lowest place value that contains a significant figure. Clear? So this measurement here is going to be what? 10,000, 11,000, 12,000, sorry, 20,000, yes, so it'll be 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that would be the next lowest place value. The estimation would be hundreds. So what would this be? This would be 1,500, 500. Is that right?
Yes.
Shall I write that a little bit better? It looks a little sloppy. It would be correct?
Yes.
This one would be right on the line. It would be,
14.
but what's the precision? Are there any zeros here that are within the precision?
Yes.
Which one?
The first one.
The first one. So we put a bar over that. Clear?
Yes.
How we doing? How's the videographer? Good?
Yeah, we're good.
Excellent. Yeah! Okay. This one would be hundredths, thousandths.
10,000.
Right? Yes or no?
Yes.
Excellent. So this one would be
0.05. 5.
right?
Yes.
This one would be
1.
4.
4.
0.
Wait. Doesn't there be a 0 before the 1?
no. First of all, yes, well done. Sorry. Well done, mister. Well done. Wow, I am impressed.
No more 0
Is that right, Nat?
Yeah.
Is that right?
Yes.
Yes?
Yes.
Okay. Is that 0 read from the instrument?
Yes.
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 Yeah.
Yes? 10 thousandths. 10 thousandths. You get it?
Yes.
Okay, now. So that's it. Should be pretty straightforward, right? But the book really doesn't do it this way. But it's important that I show you this way. Because a significant figure is anything read from an instrument. So if it's not read from an instrument, it's not significant. That's the whole point of this. Scientifically, if you go up to somebody who's a physicist and he's 80 years old and you say the word significant figure, he'll say, yeah, because it's just like such a crazy thing to learn for the first time. He's like remembering when he was a teenager and you're learning significant figures. It's so annoying. It's significant figures. 14 does not equal 14.0 scientifically. It doesn't. This has 2 significant figures, this has 3 significant figures. They're not equal. Mathematically, they're equal, the magnitudes are equal, but in terms of science, they're not equal. Isn't that annoying? It really is annoying. If the answer was 14.0 and you put 14, you wouldn't receive any credit. Am I going to test the knowledge of a 15-year-old by determining whether or not they can use a calculator and come up with the number 14? Of course not. 2 times 7 is 14. You want credit for knowing that? I don't think so. The test is, can you correctly write the answer according to the rules of measurement, accuracy, precision, and significant figures? That's what I'm testing. You get it? Okay. Yeah. So what do you do with this? Okay, this is going to be the end. Don't do it yet. This is going to be the end, and then we're going to go to another one, and we're going to wrap this up, okay? We're done.